Back in the ancient times of technology, September 1981 to be exact, sorry about that one, IP address classes were actually defined in RFC 791. And you can look up any RFC that you want to because you will run into these once in a while during your studies. You'll see them mentioned. And if you want to look it up, they're all online. And what they are, the official term is requests for comments. And they're technical proposals / documentation. Now, I will be the first to say they're not the most exciting reading around. As Scott Terrell brilliantly said about law books in 1L, it's like reading this is like stirring concrete with your eyelashes. And sometimes reading an RFC can be pretty much like that. But it is good reading, and advanced technical exams occasionally like to ask about RFC numbers for a particular protocol or network service. You're not going to see much of that on the CCENT exam. There's one number coming up, an RFC number that I want you to know because you see a certain address class referred to by this number in a lot of books. So we will see that in a moment. But again, don't worry about going out to the RFC site, memorizing a ton of numbers. You do not need to know that. One thing we do need to know, and I'm going to hammer away at this a couple of times in the next few minutes. First off, you've got to know these address classes that I've got on the board right now. You've got to be able to look in an address and immediately say, okay, I know what class this belongs to. And it's not just for your exam, it's for subnetting on your exam and real-world subnetting. You've got to know what class a certain address belongs to before you can start answering questions about it or use it in subnetting. The first octet of any Class A address is going to be 1 through 126. We are skipping 127 on purpose, and with Class B, the first octet is going to be 128 through 191. With Class C, the first octet is going to be 192 through 223. Now, the following classes are reserved and can't be assigned to host devices. Class D, first octet of 224 through 239, reserved for multicasting. Now, I mentioned here it's a topic not covered on the CCENT or CCNA exams. What I mean there is that the actual configuration of multicast groups and multicast streams, that kind of thing, that's in your CCNP studies, and I urge you to get your NP once you're done with your CCENT and your CCNA. You will, of course, we have talked about multicasting a little bit. You know what it is. It's that middle ground, remember, but right between unicast and broadcast. When you send out multicast traffic, it's going to a certain group. It's not going to just one host, and it's not meant for everybody. We'll also be working with at least one dynamic routing protocol that uses multicast. So you are going to have a couple of multicast addresses you should know that we're going to talk about in the OSPF section. You'll see what I'm talking about when we're configuring that on the live equipment. But as far as the actual configuration of multicast groups, that kind of thing, you're not going to have that on your CCENT exam. Now, finally, we have Class E, 240 through 255, reserved for future use, also called experimental addresses. Ooh, spooky. Now, let's see. Any address with a first octet of 127, that is reserved for loopback interfaces, but not for loopback interfaces on Cisco routers or switches. Now, what a loopback interface is, and we will configure them in the course, they are logical interfaces. They do not physically exist on your router or your switch. Now, there are a myriad of reasons that you would create these in production networks. We don't cover a lot of them in the CCNA, but I'll try to mention one or two as we go along. The great thing about loopback interfaces, if you have a home lab or you're doing rack rentals online, is that you can create more networks for your lab work than you have interfaces. If you just stuck with physical interfaces and you had three of them, you can only create 3 networks. But with loopbacks, you can create just about as many as you want. Again, just be able to look in an address and immediately be able to say, pardon me, don't say that. Say, yes, this belongs to a certain class, here it is, or this can or cannot be assigned to a host. Now, the reason we have to know those so cold is because it relates to subnetting as well. Because each of the 3 classes that we're going to be subnetting, A, B, and C, each one has its own default network mask, each one has its default number of network bits, and each has a default number of host bits. And we manipulate those bits when we're subnetting. So we've got to know what we're starting with in order to manipulate it correctly. And with Class A, let's scroll that on down. You've got a network mask of 255.0.0.0 to start, 8 network bits, and 24 host bits. Class B, right down the middle. Default mask 255.255.0.0, 16 network bits, and 16 host bits. And Class C, as you'd expect, the default network mask is 255.255.255.0. You have 24 network bits, and you have 8 host bits. And again, I know I'm hitting you over the head with it, but know the class, which addresses can be assigned to hosts, which ones can't be, and the mask and bit information we just went over. And when we hit subnetting, I'll be reminding you of those values. Here's that RFC number I think you should know by heart, 1918, really easy to remember. And this defines what we call private address classes. And this is something you run into if you've worked on different networks in your IT career. You'll notice that the hosts at different sites or with different companies use similar IP addresses. And that's because certain IP address ranges have been reserved for internal networks. Networks with hosts that don't need to communicate with other hosts outside their own little internal network and that don't need to access the internet. And you may already be thinking, well, that's pretty limited today. And you're right, we're getting to that. But here are those reserved ranges of addresses. Class A, 10.0.0.0 through 10.255.255.255. Anything in the middle of that, and including the 2 that you see on the screen, they're private. Class B, 172.16.0.0 through 172.31.255.255. And then finally, Class C, 192.168.0.0 through 192.168.255.255. You should also be able to identify those with prefix notation, because here are the masks that go along with that. You should know the ranges by view as well, but Class A, the reserved addresses, 10.0.0.0 network with a 255.0.0 mask, and you'll notice the /8 right here. That's prefix notation that shows that the first 8 bits of whatever mask you're using are set to 1, everything else is a 0. The Class B reserved range can be expressed in either of these 2 ways, 172.16.0.0, 255.240.0.0, or 172.16.0.0/12. Class C, 192.168.0.0, 255.255.0.0, or the much easier to say 192.168.0.0/16. If that's new to you, and give yourself a little time to grasp it, and also you might want to go through the binary and subnetting section, and this will all be a lot clearer. But again, those are just 2 different ways to express our private address ranges. Now, you're probably thinking, we use those private network addresses at our place, and we don't have any problem at all. We get out to the internet, we do all kinds of things. Well, how we make that happen are the network services NAT and PAT. Network address translation, port address translation. They make that possible, but they are not default behaviors. So these ranges by default are not routable on the net. You can't go out there if these are your source IP addresses. We are going to work with NAT and PAT later, and we'll see exactly how that works. But for our purposes right now, let's just keep in mind these private address ranges. Now let's get to that introduction to the routing process. You've heard the term routing protocol most likely. You've probably even used one of them. If you haven't, that's fine, because you're going to use a couple of them before we finish with this course. Now, before we start working with the actual routing protocols, though, we need to understand the very basics of the routing process and how routers decide where to send our packets. Now, first, we're going to take a look at a very basic setup and then follow the decision-making process from the point of view of the host and then the router. And then, once we're done there, we're going to revisit the example we saw earlier and see why it's a bad idea to have hosts from the same subnet separated by a router. So actually, we will go ahead and pause here for a moment. I'll see you on the next video, and we'll start that walkthrough. See you there.